Hey, welcome back, engineers. So we have reached our final circuit, circuit 5C. Notice we have an old device that we've used already. This is the ultrasonic distance sensor. We have our switch reconnected again, and our breadboard is communicating back with our computer, if you notice on the RX button. So this is showing that our distance sensor is communicating where it is sending its echo, and it's receiving back its information for the distance. And we will be using that information to move this device. So if you have this set up correctly, you'll notice that on your serial monitor, you'll have your distance being sensed. So if we move this device around, we detect different distances for the nearest object that is detected. Okay, so now let's see what happens. So if I turn on the device, if there's no object being detected that is close, then the robot will want to move forward nonstop. So if I put it like this, it will want to keep going backwards and backwards and backwards until it can move forward. So if you set up your robot correctly, it should be moving like this. We will see similarities between circuit 5C and circuit 3B and 3C, where we use an ultrasonic distance sensor to control a servo motor. So in lines 31 and 32, we identify our trig pin and echo pin. This is being used to calculate the distance. So we also have backup time and turn time. So with these values, we can adjust these to change the amount of time the robot is going either backwards or turning for. Notice down here, we identify our trig pin as an output and our echo pin as an input. Here, we are serial printing our distance term. We're also serial printing our distance value, and we're also including our unit of measurement, which is inches. In this section here, we use if and else statements to make our robot move. So notice if our distance is less than 10, our robot will stop, go backwards, and turn. If there is no object being detected at a distance of less than 10, then our robot will continue to move forward. And then we close this entire section here so that if our switch is not in a low position, then our entire robot is just off. And finally, this is the other portion of the code. We don't need to mess with this. This is math that is being used to calculate the distance. So for challenge 1, we want to change the distance at which the robot reacts. So if we look at the code, we notice that if our distance is less than 10, then our robot will react at that distance. So we can change this to allow the robot to move continuously until it detects an object at 5 inches away, or even 20 inches away, or even 100 inches away. So work with this and you can try it out and mess with the distance. I'm not going to upload this code since you guys have been going through this for so long now. The second challenge, change the behavior of the robot when it senses an obstacle. So you have several options for this one. We can mess with our right motor, left motor values, and we can adjust the speed. So we can say that if the object is detected at less than 20, then we can say, hey, back up for a longer amount of time. Notice how it says backup time. So we can change this predetermined value to, let's say, 1,000 or even 10 seconds. So it'll just keep backing up for 10 seconds. All right, but that seems kind of excessive. Maybe it'll fall off a cliff. So you can change that if you want to. You can also make it move forward at a slower speed. But either way, the robot detects an object and it instantaneously adjusts by going through this additional code here. So once again, to change your robot's behavior, either add different right and left motor and delay functions, or change these values here. That's pretty much it. Try it out on your own. You guys are awesome. Thank you for joining me.